Hello everyone. Myself, Dr. Suhas Vyas from Department of Life Sciences, Bhakt Kavi Narsimha Mehta University in Junagadh. Today, it's my privilege and honor that I have been invited for the lecture in a refresher course from Gujarat University, and I also appreciate my sense of gratitude towards the coordinators as well as towards the MHRD department of Gujarat University as well as the Honorable Vice Chancellor. So today I will be discussing on different aspects of climate change, and out of various aspects of the climate change, we have all heard the name that is the climate change. But in fact, what is this climate change, and how can we mitigate this, and how can we find the solution of these climate change? Not we'll talk about all these different aspects or different divisions of this climate change or what are the effects, but I will take one of the topic which is right now considered to be an important one, because there are various provisions of of finding any solutions, but naturally we can help this particular thing, that is to remediate or to mitigate the climate change in terms of carbon sequestration, that is carbon capturing. So nature has its own way of finding the solutions, but rather we go towards the crucial way of finding solutions, which is led by the nature itself. As in these times, we are very much aware about the pandemic situation. That is its cruel way of finding the solution. That is the prevailing the various types of diseases. But in all, we human beings, which are considered to be the beginner of this climate change impact, they are itself to find the solution. So we will move the whole lecture towards those finding the solution component of this uh, global warming, as well as some of the aspects of the climate change. So, in all, we'll be discussing about the what we call as carbon sequestration, and how with this can be remediated or what we call mitigating the climate change. So, we will move on towards the slide, which will be in your screen. That is, I'll just share the screen and slides which is going to come is the title slide, and this is the topic which we will be focusing on throughout my uh, journey of this particular lecture. So this is about the dimension of the carbon capture through the blue carbon. So we will be discussing on how this is being captured by the different natural habitats, and these natural habitats are the amount of resources which are available in this nature. So this is the aspect where we will be discussing on. And what is this blue carbon? This will be the title of our talk, that is dimension of carbon capture and the blue carbon. The focus of this particular lecture will be on the status of the carbon emission, as well as the effect of carbon emission. What are the effects which are being faced by the living organisms, as well as what is the major solution of this excess of carbon which is being emitted by the human being itself. So we will be having three phases of this particular session, that is status, that is what is the condition of the carbon emission, how far we have reached towards this carbon emission, as well as what are its effects on this carbon emission on the living organisms and the abiotic factors, and the important one, that is the solution. Now we all have came across the word, that is the climate change. This climate change is is a broader term, as we all know that it is really a very broader term, but we need to find that what are the aspects which are included in this whole broad term. Most of these climate changes are attributed towards very small variations in the Earth's orbit that change the amount of the solar energy, or as well as the planet which are receiving those energies from the solar radiations. So very small changes or variations in the Earth's orbit can also affect these climate changes. We are all familiar with these, some of the aspects of the climate change. The current warming trend is of particular significance because most of it is extremely great, that is extremely likely to be the result of human activity since mid 20th century. Because you may be aware that the the current situation of this climate change has came just due to the human beings. That is, we all human beings have created this scenario or this circumstances that we are facing the climate change. And now what we are doing, we are accessing, or we are expecting that some other living organisms can have the solution for this climate change, which we itself have created the problem. So we have to bring the solution by ourselves, not we have to depend on the other organisms to find a solution. The heat which is being trapping the nature of the carbon dioxide and other gases was demonstrated in 19th century. That is, the carbon dioxide which is being trapped by the nature in the atmosphere, that predicted that there is something which is being changing the atmospheric conditions, or that is likely to be the climate change in the near future, and what we all are facing right now. Scientific evidence for warming of the climate system is always an unequivocal, because one scientist will show its own evidences which he or she has brought about from his scientific data. Some other scientists may also give their own data that is being generated by them through different types of experiment on the climatological studies. So they may have a significant variations itself in their data, but the fact is that they are having the variations. The point is that they are having the variations. Hence, this has led to the scientific evidence which is of unequivocal. That is, that there may be some of the differences, but they are not to be neglected. So if you see on the screen the slide which is being shown, that is, we are in this particular situation. That is, we need still the more evidences. Though we are in the climate change, we still find that there are lack of evidences which can prove that there is a climate change. But in fact, we are affecting, or we are also having those effects. That is nothing but the climate change. For example, the person who is in that particular water, that is nothing but the sea level rise. And we are finding the evidence. No, we need to do something. We need to take a step very much towards the mitigation of the climate change. We human beings have the should find the solutions to mitigate these climate change effects. Now, as a part of the status of this climate change, as I told you in the earlier slides, that is, the evidence of the climate change are likely to be formed during the 19th century. So if you see the graph, particularly in the screen, there is a slight variation in the level of the sea, what we call it as a sea level rise. Now, this sea level rise, what I called it as a slight variation, but it on a larger scale, if you see that, it is very much drastically having the effect on the living organisms, on various types of living organisms surviving on the earth. So per year, the NASA has predicted or has found the data that per year 3.22 millimeter is being a rise in the level of the sea. Just imagine, from 1995 towards the 2020, it has increased to that much of variation, that is 3.22 mm, and it is increasing. It is increasing very much drastically through this climate change. Now we are talking about just the climate change. We are not going in detail about each and every aspect of the climate change, but in this particular session we will be discussing about one of the aspects due to which the climate change has occurred. And the effect can also be seen through this sea level rise, that is about 3.22 millimeter per year. Per year, you can imagine from 1995 or or ahead of the 1995, there were rises in the sea level, but it has drastically increased in the last century. So that was the sea level rise, and if you consider the temperature rise, it is also not behind. This temperature rise has been shown in the screen, that has increased the temperature anomaly through last century. So in 19th century, you see there is in the minus, that is, it is degree Celsius, it is showing in the screen, that is not that much having a significant variation. But since last 19th century, it has been it is being shown very much clearly that during 2020, the temperature has gone up to 1 degree Celsius. The difference in the temperature has reached towards the 1 degree Celsius, and 1 degree Celsius is an average temperature which is being measured, that has changed the climatic condition. Now, when we think that, oh, 1 degree Celsius, it may not take that much difference, but 1 degree Celsius temperature on an average creates an imbalance in the living organisms, not only in the biotic conditions, but also it has a higher impact on the abiotic condition as well. So considering the sea level rise, which has increased up to 3.22 millimeter per year, or which is in the increasing ratio of 3.22 millimeter per year, it has also increased the temperature. Now I'm talking that why these are the effects, these are the status, or we can say that these are the variations in the parameters like sea level rise, or it may be in the temperature, but they are being caused by some of the situations which creates these types of factors, or these types of environment. Now, we may have experienced in this particular, the people who are the population in this particular generation have may have experienced the temperature variations, right? The temperature variation in terms of minimum as well as in terms of maximum. So if you consider minimum temperature, maybe towards, as far as human beings or in the planet which is being on the Asiatic conditions, it may be reached towards the 6 degrees Celsius, 7 degrees Celsius, and up to the highest temperatures having also observed up to 48, 49 degrees Celsius. You just imagine that the variation in the temperatures from on an average, I'm talking about, that is from 5 to 6 degrees Celsius towards just 49, 50 degrees Celsius. So the difference in these two temperatures are showing itself the evidence that what a drastic change has been occurred due to the climate change, due to the variations. So in the graph shown in the screen, you can clearly identify that the temperature has changed or has shifted the increase on the average temperature, so it means a lot. It means a lot that there were cold times, there were hot times, but they were not that much having the difference. But now we are observing those differences on extreme limits. The minimum is more minimum, and the maximum is more maximum. Considering these aspects, there are also some of the species, maybe of the plants as well as animals, have been extinct. They are on the verge of extinct due to such variation in temperature itself. So I'm talking about just only one of the factors, that is the temperature, which has caused towards the survival issues for the living organisms. So we have seen about the sea level rise, which has increased. We have also talked about the temperatures, with variation in the temperatures, that is increase of about 1 degree Celsius in the temperatures through 19th century towards this 2020. So if you see, there is also, we are moving ahead now towards our concrete of the basic theme of our topic today, that is greenhouse. There are, we may have heard about different types of greenhouse gases. These are some of them, that is carbon dioxide, methane, nitrous oxide. So all these gases have increased its concentration in the atmosphere, and this has also shown a heavier effects on the living organisms. If we talk on each and every aspect of these gases, it may take number of series of lectures. But talking about only couple of them may build some of the highlights how these gases affect the living organisms and what are its mitigative measures which are to be taken to decrease these greenhouse gases. So carbon dioxide, methane, as well as nitrous gases have lift themselves up towards increasing the concentration through different sources which are being generally used by the living, that is especially the human beings. So if you consider about 400 ppm of carbon dioxide, just carbon dioxide, 400, it is near about 400 ppm. So that has, I'm talking about 20 years back, but now the situation is it has reached towards the 400 ppm carbon dioxide in the atmosphere. And as a whole of the carbon dioxide, we are not looking in different gases of the greenhouse gases, but simply carbon dioxide has crossed the limit of 400 ppm, which is the highest peak in the particular century. So this carbon dioxide has led towards different different problems which are being faced by the community of different organisms. So we'll look into the matter that how these greenhouse gases warm our planet. Now, there are various slides which are showing that these are the gases which are on this particular extinct. If you consider the carbon dioxide, it is about 1 GWP, that is global warming potential. It has only 1% of the potential of the whole carbon dioxide, whole greenhouse gases which has been liberated. But other than this carbon dioxide, there is fluorinated gases which includes about potential of 1,000 to 10,000 GWP warming potentials, right? So, of human generated greenhouse gases is a measure of how much heat each gas traps in the atmosphere. So, only about 1% for carbon dioxide, and the maximum is the fluorinated gases, that is about reaching up to towards 1,000 to 10,000 GWP. So this is just in relation, carbon dioxide in relation to other gases of the greenhouse. So we can understand that how much each human caused greenhouse gas contribute towards the total emission around the globe. When we talk about the whole earth, whole all the countries which are contributing towards the emission of the greenhouse gases, out of that about 76% of the greenhouse gases that is enriched with the carbon dioxide. You just imagine. So this percentage is on the higher side, which is being contributed by the human beings towards the total greenhouse gas emission, that is of 76% of the carbon dioxide. So it is one third of the gases which are being considered to be the greenhouse gases which are being emitted, and this plays a major role in the climate change. What I mean to say is that we have to concentrate on the capturing of this carbon dioxide, as this carbon dioxide is being now considered to be at the peak of its level for damaging, for destructing the organisms at its own in its own potential. So if we just talk and talk on these carbon dioxide emission as well as on the solutions, it will not be the and when we go for the implementation, then it can mitigate the process of reducing the carbon dioxide in the atmosphere. So as we on the last slide we have shown that 76% is the carbon dioxide which is being emitted by the human beings throughout the globe. One third. This carbon emission is the major source of different fossil fuels which are being burned. And out of that, for those fossil fuels we already know about, because we have consumed in such a quantity, it reached towards the 76% of the total emission of carbon dioxide, that is petroleum, coal, natural gas, cement production, etc. All these gases have have emitted in form of carbon emission, in the form of carbon emission. Coal, which we burnt, obviously it will turn into carbon dioxide and be released or emitted in the atmosphere. Cement, when it is produced, we all know there are thermal power stations, they all emit the carbon. Petroleum, when we burned in the fuel in the vehicles or in the heavy vehicles, they all contribute towards the emission of the carbon dioxide and hence carbon is emitted so frequently that it has reached towards about more than 6,500 million metric tons of carbon per year. Just imagine, it is per year values. So it is a highly alarming situation for us to mitigate the carbon source as well as to mitigate the carbon emission along with the greenhouse gases. Now, in terms of the emission or the fossil fuel which are being emitted in the form of carbon, we are having different sectors, right? These sectors that are called as energy sectors for emission of the carbon dioxide, there may be transportation. We definitely cannot disagree with that. That is about 24% of the transportation are consuming or emitting the carbon dioxide, right? That is the carbon emission. And almost about 40 percentage plus the industrial 22 percentage are being emitting the carbon. These values are also considered to be on the higher note because 40 as well as 22% contribute towards on the higher side, right? That is emission of carbon. Now here comes the controversial issue, that is, on one side we also need the economy, on the other side we also have to save our ecology, right? So we have economy, we have ecology, but what we are thinking or what we are focusing on today, that is economy versus ecology. But that is not true. We should join hands with the ecology as well as with the economy, what we call it as a sustainable development, right? Sustainable development, that sustainable development will result us in in a better way, that is also saving the ecology and also increasing the economy. So this situation can be created by finding or by joining hands with the ecology as well as with the economic aspect perspectives. Similarly, if you see the world energy consumption by the fuel during 1990 and a part of it that is in the future aspects or in the we can say as a trajectory score in 2035 in form of quadrillion British thermal units, that has also seen that there may be natural gases, there are renewable resources which also will be projected in the near future, as all the countries in the Paris summit, we may have been came across with the Paris summit that um, there are mitigations or there are steps which are to be taken compulsorily by each and every government of the different countries to utilize the renewable energy more in terms of the non-renewable energy resources. Hence, these are the some of the values that are shown in the British thermal units. That is about 150 towards for the liquids of different kinds of emitting from the carbon in the atmosphere. The rate of the increase of the atmospheric carbon dioxide over the past 70 years is nearly about 100 times larger. Just imagine, it has increased 100 times larger in the last 70 years itself. That what we call it as an industrial revolution. Right, this industrial revolution has no doubtedly it has increased the lifestyle, it has increased the standard of livings of the human beings. But on the other side, if you see the atmosphere, the environment, it has also drastically degraded the environment in terms of emission of the carbon dioxide in 100 times ratio in last 70 years than that at the end of the last ice age. Now we know that last ice age is nothing but before about 1000 to 1100 years before. So before 1000 years, when we had the carbon dioxide which was easily captured, whatever it was being generated, it was easily captured. But In the last 70 years, it has increased a lot. It has almost doubled the emission of the carbon. So emission of the carbon dioxide from the human activities itself were again at the record levels in 2016, just before couple of years before. So in 2000, although according to most recent assessment of the global carbon project, the year-to-year increase of these emissions has slowed down or even reached at a plateau. So it's a projected score where it was said that after 2016, after negotiating after in the Paris summit, as well as by the steps taken by different countries, it was being decided to minimize the carbon emission so that the carbon can be easily captured by the natural resources as well as by different types of technology. Now, as the word technology, if you see uh, the present generation, the present generation is having the capabilities as well as it is having the technologies also. So we have both the aspects in the present generation. It has immense amount of capabilities, immense amount of technologies. Now what we are focusing on, that is to be chosen. Are we focusing on the technologies? Yes, we are focusing on technologies, and which is a very good sign. And we have to utilize the capabilities as well as the technologies in the capturing of this carbon. This greenhouse gas has led to disturbance in the overall environment of in which the human beings are able to survive. Now, the first problem, what we call due to the climate change, which has evolved on a major scale, that is population. That is, we are talking about population. We are talking about sea level rise. We are talking about different resources which are getting degraded day by day due to the climate change. But those resources are degraded by the human activities itself, right? So we need to understand where these capabilities and technologies are to be utilized. We have to utilize in the correct path for mitigating this carbon emission. Now, this is just an example. I have kept this slide just to realize that how much emission of carbon individual person is emitting in the atmosphere or in the environment. Just consider the manufacturing the average smartphone, which is estimated to create around 16 kg of carbon dioxide emission. Equivalent emission, right? So an average smartphone is having a capacity to emit almost about 16 kilogram of carbon dioxide just when it is manufactured. I hope you are having a careful understanding of this particular example. That is, smartphone when it is manufactured, it is having 16. It is having the capacity of emitting 16 kilogram of carbon dioxide, and when it is being utilized, obviously we need to charge the phone. We need to give power towards the phone, and on an average, the data of the one of the review article as well as research paper showed that on an average a smartphone is utilized for almost maximum, or we can have a range of about 2 years, of 2 years. And to figure it out, from 16 kg of carbon dioxide when it was emitted, now that 16 kg has increased due to the power consumption by that phone, and we need to charge that phone where it is supplied, that is 22 kg. So it has increased from 16 towards the 22 kg of carbon emission. This is the single smartphone that consumes, or that about that is being having the capacity of emitting carbon dioxide of about 22 kg, right? 22 kg. Now it is just a value of one single smartphone. The number of smartphones user by in the mobile, that is mobile phones throughout the world, currently is about 2.54 billion. You just imagine. So we need to calculate 2.54 billion into 22 kg. 22 kg is the carbon dioxide or which is being emitted by one single smartphone. This smartphone, there are various types or categories of the smartphone, hence the number of the smartphone users in the world is about 2.54 billion. This 2.54 billion reaches towards, in the terms or in the value of carbon dioxide emission, is about 1.25 million tons of carbon emitted. I'm just having one single example, which is being which is has the 1/4 of the percentage of the current global emission of the carbon dioxide. That is the smartphone. So before utilizing the smartphone, before purchasing the smartphone, try to figure it out how much carbon emission is being emitted from that particular smartphone. So this is the example which I want to take to share with you, that how a single person has the is being emitting the carbon dioxide in the atmosphere, knowingly as well as unknowingly, right? Knowingly and because we are not that much familiar with the emission of the carbon for each and every product which we are utilizing today. So, with that example, I would like to link the effects of these climate change. These climate change have various effects on different abiotic conditions. On different abiotic, I'm not talking about biotic conditions, but I'm just taking one of the point, that is on abiotic conditions. Now, these abiotic conditions are obviously on the oceanic side, on the land side, that is on the terrestrial, as well as the icing effect. This ice is, we are all familiar with the shrinking of the annual average Arctic ice, that is what we call it as a glaciers melting, right? These glaciers are being melted due to the temperature rise, as I referred in the last slides. That is about 1 degree Celsius of temperature are being, on an average, is being increased per year. So this increase in the temperature has resulted in the shrinking, or we can say in the melting of the Arctic ice. So talking about the ocean are being warming throughout much of the world's ocean. They are increased in the temperature. The temperature of the ocean is also increased, due to which there is increase in the rates of the global mean sea level rise. As the temperature increases, obviously the rise in the level of the sea also increases due to the melting of the glaciers. They are interconnected. The ice as well as the ocean can be interconnected, because as the glaciers will be melting, obviously the sea level will be rising, and due to which and one of the important aspect of the climate change, that is change in the ocean salinity. We all know that about 1/3 of the earth is being having the oceanic part, that is having the water, and this water is nothing but the ocean. So if it changes its salinity, or if it changes in one of the parameter of the conditions, about the condition of the water, maybe say any of the mineral, maybe any of the sediment part, this can result into effect of the organisms which are surviving in the marine habitats, right? So any change in the salinity or in any of the abiotic conditions of the water of the ocean can have an adverse effect on the organisms which are surviving. And another point which I have highlighted over in the red color, that is ocean acidification. Now, one of the interesting concern in the environmental effects or in the climate change, that is the ocean acidification. Now, as we all know that there are various anthropogenic activities which are being followed by different continents, right? Living organisms. So after all, whatever gases are being emitted, whichever gases are emitted, say about different greenhouse gases, as we have discussed earlier. So these greenhouse gases effect on the atmosphere primarily, right? They will be emitted from the source. These emission will be traveling through different areas, and these gases, when they come over the ocean, they will be readily absorbed. I repeat, they will be readily absorbed by the ocean. This condition will create change in the pH of the ocean. Carbon will be dissolved in the ocean, what we call as a dissolved carbon dioxide. This carbon, when it is dissolved in the ocean, in the marine water, this has changed the pH of the ocean, and it has decreased the pH of the ocean. That is, it has moved towards the acidic condition. This acidic condition has a great effect on different organisms surviving, maybe the grasses, that is sea grasses, as well as maybe different zooplanktons, animals which are surviving in the marine habitats, right? So acidification has been now increased towards on a larger scale. As I told you, one third portion of the earth is being covered by the ocean. So you just imagine, when this one third portion gets acidified, how come the mainland organisms will able to survive? Because the whole cycle of the nature will be turning from ocean towards the terrestrial and the atmosphere. So this cycle will also get disturbed. So any of the aspect you pick up in the climate change is interconnected with the other one, and if we need to find a solution of one, we have the obviously the subsequently we will be mitigating the other effect also. And this ocean acidification is considered to be one of the important criteria, or one of the important effect of the climate change, because oceans are giving us a lot. They are one of the major source of different types of organisms, as well as different types of abiotic conditions. The other effect is also being seen frequently in on the land areas, that what we discussed earlier, that is the extreme effects, that is maybe about extreme temperatures, that is lowest temperature as well as the highest temperature. Reduction in the number of frost days, that is number of what we call it as a winter days are also being shortened than compared to that of the earlier stages. Decreasing the snow cover in the most regions, as I told you, that it is in the ice is getting started to be melting, and these ices are nothing but glaciers. Large scale precipitation changes. Now, one of the example we can also understand, that is earlier in the earlier times, that is in the 19th century, we observed the rainfall. That rainfall was consistent in terms of its range. But nowadays, if you observe very much carefully, there are flood situations which are happening. We are observing the flood situations in throughout the world. There are many countries who are facing the floods, as well as different areas of the coastal region are also facing the tsunami. So due to these, what has affected, that is the intensity of the rain has been changed. The amount of rain which was which was coming earlier in the, say, about 19th century, the amount of rain was about, for example, 20 centimeters was falling in terms of rainfall in about 1 month. But nowadays we are observing about 2 to 3 inches per day. There are some situations where in 1 hour there are 4 to 5 inches. Hence the intensity of the rainfall has changed. It is coming in a lot. That is change in the precipitation. So large changes are also observed in the rainfall, increase in the number of heavy precipitation events, as I told you. So the intensity of the rainfall has changed very much adversely in compared to of the 19th century. So these are some of the effects which are being observed due to the climate change. Now, considering the biotic condition, as far as we are concerned, the living organisms are concerned, we are generating those pollutants in terms of greenhouse gases, and we are also having its own adverse effect. Hence, we are one of the victim, and we are one of the source. So we need to understand this very much carefully, that on which way we are proceeding. So the carbon dioxide toxicity has an immense effect in different parts of our body. This slide shows majority of the main symptoms which are being caused due to the carbon dioxide toxicity. Now, if you see, starting from the top, that is head, towards the muscular tumor of the body, muscular part of the body, we are facing different types of diseases which can be prevailed due to the toxicity or increase in the carbon dioxide when it is inhaled in the body, or when it is being exposed towards the carbon dioxide, right? For example, there are drowsiness, we also find dizziness, headaches are just very much frequently observed in terms of increase in the carbon dioxide level in the atmosphere as well as in the surrounding, in the environment. So it decreases the respiratory control. That is about, we are having an experience of about breathing very much short. That is shortness of our breath, that is effect on the respiratory system, skin, heart, visual symptoms, auditory symptoms, muscular symptoms, etc. There are various other types of symptoms which are nowadays frequently observed in the human beings. So this is the effect of the climate change. In the first slide, in the previous slide, I had shown you about the abiotic condition, but this slide is being just one of the example of the biotic condition. I'm not going into the detail of about different species of the living organisms, maybe bacteria, maybe any of the plants or any diversity factor, but what human beings are suffering or will be suffering based on the toxicity, increase in toxicity of carbon dioxide, is just shown in this one particular slide. There are various different diseases also which can be prevailed through the carbon dioxide toxicity. So we need to take very much seriously this climate change effect. So the point is to mitigate. The point is to find a solution. So this solution is nothing to capture or to sequester the carbon, because right now, what is the status? The status is, we are that is, the earth is being surrounded by a suicide belt, and this suicide belt has been created by human beings itself. So this belt, we need to now reorganize it. Now, how we can reorganize it? We need to find solutions, and these solutions is nothing but to capture the carbon or to minimize the emission. There can be two ways. One is to minimize the emission of carbon or as well as other greenhouse gases from different sources, maybe industrial, maybe transportation, or maybe some other sources also. And the other point, that is to capture the carbon. We need to capture the carbon. We need to have more sources or more resources that can capture in a good quantity of carbon from the atmosphere. We need to understand that. This is the understanding which, if we are not following that understanding, that is to capture the carbon or to minimize the emission of the carbon, or then it will be a burden for the human beings or for the population in different aspects, in different types. For example, this particular slide, if you see, melting Arctic, droughts, floods, food crisis, massive extinction, that is mass extinction of different species. There are various species which has been degraded. There are various species which are being endangered in the red data book. So all these species are getting degraded as well as they are being on the verge of extinction. These are nothing but the effect of, or the emission of the carbon which has increased a lot. Acidifying the seas, we are facing, this generation is facing all these crises, and these crises are nothing but the burden of carbon. We have emitted lots of carbon, but now is the time to alarm ourselves, to take steps, as well as to take some of the measures which can reduce the emission as well as which can also capture the carbon. Now this carbon is, as I told you, it is heavily dangerous if we are not stopping that emission, or we are not doing any solution about the carbon. We might have came across the word what we call it as a carbon footprint. The figure is a very is showing a posture of the leg, that is the foot, and the carbon which is being emitted, that is carbon footprint. But the fact is that we are also following the same scenario. We are emitting the carbon, as well as we are also finding its effect on the disadvantaged side, on the disastrous side, that effect which is also being faced by the human beings. So we are only the person, we are only the population who are emitting the carbon, and we are only the population who are experiencing its adverse effect of that carbon dioxide. This, if you consider as a whole, different countries, if you compare India with different developed countries, because I'm talking about developed countries because India is nowadays considered to be on a developing stage, right? Compared to that of America, US, UK, etc. All these companies have developed, all countries have developed itself, but India is on the developing stage. This developing countries like India, developing countries have rarely any footprints compared to that of the major developed countries. They are showing that the countries which are underdeveloped or developing countries, they are exposing the carbon or they are emitting the carbon. But the true fact is that the majority of the reviews literature shows that the developed countries have a higher footprints. There are rarely any footprints by the developing countries, right? We need to understand very carefully about these things, that we have uh, the ability we have the ability to find a solution of this carbon dioxide which is being emitted by the different resources by the developed countries, and we need to find the solution by the nature itself, by the nature itself. If we are having any conventional methods which can reduce the, there are also non-conventional methods which can be utilized for carbon capturing. Hence, talking about the alarming situation, we are in this particular posture. We are sleeping right now. The emission of the carbon is being done efficiently, as well as if it is done enormously. We need to get alert. We need to get alarmed by the situation or the circumstances which are being observed today in the 20th century. This alarming situation was estimated by the Intergovernmental Panel of Climate Change, what is familiar with IPCC. It estimated that by the year 2050, in the year 2050, global carbon emission must be reduced by 85%. Just imagine, it should be reduced by 85% during 2050. One more thing which has been informed by the United Nations during its last meeting about the climate change was that if we are not able to set our goals, that is decreasing the carbon emission by 85%, if we are not able to reach this particular goal, then what will happen? In 2075, in 2075, we may be alive or we may not be alive. In 2075, the amount of carbon dioxide, the amount of carbon dioxide will be increased drastically if we are not reaching towards this 85%. It will still increase, and the result of which is already being seen, that is about increase in the temperature of 1 degree Celsius will be a global mean of about 2 degrees Celsius of increase in the temperature. It is really a very challenging. It is really very challenging. So for that, there are various steps which are to be taken, and these steps, as I told you, for the controlling the carbon sequestration is carbon reduction of the anthropogenic activities through different sources, that is to mitigate it, as well as the carbon uptake. the carbon dioxide uptake as well as the storage through conservation of natural ecosystems, because nature has the capabilities to control any situation. It may be crucial, it may be very much harsh, it may be very cruel, as we are facing today. It may be very cruel, but it has its own plans, it has its own limits. If we are crossing its limit, then nature will play its role. So before nature plays on a crucial or on a cruel side, we need to alert ourselves that we need to develop, we need to conserve, we need to restore the systems which were already being done by the nature in terms of natural ecosystems. Considering the natural sources which can be used to capture the carbon, the two important ecosystems, that is terrestrial ecosystem as well as the coastal ecosystems, they are considered to be the important one. But now within the natural ecosystems, terrestrial as well as coastal ecosystem, the coastal ecosystem which the United Nations prefers, or different summits were being analyzed, and after the analysis they came to know that coastal ecosystem is the world's oceans, that is the primary long term sink. It can be considered to be a long term sink for human caused carbon dioxide emission. It can it can have more concentration of carbon to be captured compared to that of the terrestrial ecosystem, currently accounting for a global net uptake of about 2 gigatons of carbon annually. 2 gigatons of carbon is being captured by the coastal ecosystem annually. While absorbing the atmospheric carbon dioxide, these reactions causes the oceans to become more acidic, because what, as I told you, the ocean acidification, the point of ocean is there are various examples, or we can say that the ocean acidification has resulted into a disastrous loss in the diversity of the ocean, marine diversity. We have lost many of the species, and we are on the verge of losing many of the species due to the acidic conditions of the ocean. So this carbon dioxide naturally is to be uptaken naturally by any of the ecosystem. This ecosystem may be terrestrial or maybe any of the marine ecosystem, what we call it as an oceanic ecosystem. Carbon dioxide may be captured by the ocean, but along with the ocean, we are all familiar that this carbon dioxide is creating an acidic condition in the ocean, that we call it as a ocean acidification. The term carbon sequestration is used to describe both the natural as well as deliberate processes by which carbon dioxide is either removed from the atmosphere or it may be diverted from the emission sources. So we need to understand this very much carefully, that when it is being emitted, it also, whatever it is emitted, it also to be stored somewhere. It is also, right now the position is it is being exposed in the environment, due to which we are facing the problems. This storage can be done by ocean, can be done by terrestrial, as well as can be done by environment, terrestrial environments, that is vegetation, soil, and the sediments on the geological formation. Now, a couple of years back, the important point of the session, of today's session, that is, a couple of years back, when they were talking about the climate change, the ocean acidification, and all those effects of the climate change, which were revealed through different sort of panels by different scientists as well as different dignitaries, what they found, that as the ocean can absorb carbon dioxide, so there come organisms, living organisms, which can also tolerate this carbon dioxide. So why not to analyze the habitats which are surviving in the marine environment, in the marine habitats, the habitats, that is the organisms which are surviving, and these organisms, especially the plants which are surviving in highly saline conditions, that is in the marine conditions, they may have some of the ability to capture the carbon. Can we compare with these about with the terrestrial as well as the marine plants? Okay. Then after the analysis, after their work, they found out there was a positive atmosphere. There was a positive reaction between the scientists, and this reaction was due to the coastal plants. These coastal plants have immense capability to capture the carbon. So this was being studied very much thoroughly, and they found a way that this carbon can be stored, can be captured, can be sequestered from the coastal belt itself, from the coastal belt. Now, this coastal belt, I mean to say, is that by the plants which are surviving on the coastal areas, and hence they found it that one of the natural dimensions, one of the natural resources that can help to capture the carbon from the atmosphere is the nature itself, that is the coastal plants, coastal vegetation. Now this can be considered to be a solution towards the carbon capture. Now this carbon which is being captured by the plants which are surviving on the coastal belts, on the oceanic condition, on the marine ecosystem, they referred it as a blue carbon. This blue carbon was studied very much thoroughly, because we all know that there is a variety of organisms which are surviving on the oceanic belt, that is on the different coastal areas. The slide over here is that there are variations in the species. There may be grasses, that is called as the sea grasses. There may be salt marshes. These salt marshes, as well as the third category, is the mangroves. Mangroves are specific habitats, salt marshes are specific habitats, sea grasses are specific habitats which can accumulate carbon in a larger quantity than what it was expected. This carbon capacity or carbon capturing capacity of these vegetation has given a solution of capturing or sequestering the carbon, right? So these are the three major components which can help in capturing the carbon, and this was referred as blue carbon. Now we need to understand, throughout the world, to different countries which can be seen on this particular slide, that is at the map of the world, that is about the belt of the carbon, the belt of the coastal areas. The carbon can be assimilated in form of blue carbon, right? And the ecosystem may be a sea grasses, maybe salt marshes, as well as maybe the mangrove ecosystems, right? So all these vegetations can help us to accumulate the carbon which is being emitted by the human resources. Our oceans are critically important to the climate change, very much important, and the and also for the global carbon cycle. Certain coastal as well as marine ecosystems such as mangrove forests, salt marshes, sea grasses, as well as the kelp forests, which absorbs as well as store the atmospheric carbon dioxide, which help to mitigate the carbon capture. Carbon capture, which is right now can be accumulated by the coastal plants. These valuable ecosystems hold vast carbon reserves. They sequester atmospheric carbon dioxide through primary production and then deposit it in their sediments. They absorb, they store, and deposit in their sediment. It's a simple chain for the plants who are surviving in the marine habitats. These blue carbon ecosystems are extremely effective in storing the carbon. It was understood by the United Nations that we have an option, we have an opportunity, actually, we have an opportunity to mitigate through the carbon, that is through the blue carbon. This blue carbon is nothing but the coastal ecosystem. The coastal ecosystem includes mangrove, seagrasses, as well as the salt marshes. It was unbelievable that mangrove and coastal wetlands store about 50 times more carbon than the tropical forest area. You just imagine, comparatively to the tropical forest, that is to the tropical forest area, these blue carbon ecosystem can have about 50% or 50 times more carbon than the forest areas of the tropical region. So this is all about the whole one slide. We might have seen in many of the graphical presentations earlier also. Carbon which is being fixed, that is atmospheric carbon which is being fixed, mixed in the ocean, can be accumulated by the mangroves. These mangroves supply these towards the salt marsh as well as towards the sediment. Sediments play their role, as well as seagrasses also capture. They can form a very important chain in converting the chemicals of in different association of the carbon in different components. Carbon sequester is nothing but carbon stored in the soil, as well as carbon which is stored in the form of biomass. Stored in the soil is in form of sediments. Biomass is nothing but the organisms, that is the plants which are surviving in the coastal belt. Now, I told you about the blue carbon. This blue carbon is the coastal plants which are being growing on the marine ecosystem, seagrass, mangroves, as well as the salt marshes. Now, what is the significance, or what is the special about these blue carbon ecosystem? Now we need to understand about the its special significance, that is its special ecological importance, we can say, that is conserving the biodiversity, as well as and the capturing the carbon. The two important points to be discussed, or to be considered to be an ecological significance of the blue carbon ecosystem, that is biodiversity and carbon capture. Blue carbon are critical habitats for marine species that make up major parts of the people's food security and the incomes. We know that there are various countries who are on the oceanic belts. The people around the oceanic belts on the coastal areas, their income or their survival is on the marine organisms, maybe plants or maybe any of the animals, right? So they secure their food, they secure their income. Economy is also depending on the biodiversity of the coastal areas, and they improve and maintain the quality of the water as well of the coastal lines. And the important part is the carbon capturing, because right now the position is that carbon is being emitted immensely, which is to be sequestered. Carbon sequestration, it is the compelling fact that the long term sequestration is required of carbon by 1 kilometer of mangrove area is equivalent to about 50 kilometers of the tropical rainforest, right? As I told you earlier also, that it is 50 times more. The blue carbon has the capacity to acquire or to capture the carbon 50 times more than that of the tropical rainforest. Unlike the terrestrial ecosystem, carbon stored in the coastal soil can remain trapped for a long period of times. Right? We have biomass, that is in terms of mangrove, salt marsh, or seagrasses. We also have the sediments, that is considered to be the capturing of the carbon. In these places, the low oxygen condition in the soil below the water can lock the carbon for centuries and towards the millennia. Right? Not only the biomass they are generating, but also they have the immense capacity to be trapped in the sediments, as there is a low oxygen availability, and hence the carbon can be easily captured or locked in the sediments below for centuries and centuries. Right? Now if you consider the difference within the different habitats of the temperate or of the terrestrial part, if you see the area which is being covered by the mangroves, the carbon which is being absorbed by the mangroves, as well as different areas, can be represented in this particular graph. If you see the ecosystem of the carbon storage as a whole, in terms of hat-trick turns. If you see, uh, mangrove is at the top. Mangrove obviously is at the top. If you consider it above, or if you consider it as a below the ground area, the below ground area of the mangrove ecosystem has the highest amount of carbon capturing. Highest amount. Best carbon capturing is only done by the mangrove ecosystems, mangrove habitats. This mangrove habitat throughout the coastal belt of any of the coastal countries can be a most advantageous for capturing the carbon compared to that of other. You can clearly identify the boreal, the temperate, the tropical, and the highest peak is of the mangrove ecosystem, right? On the other side, if you see different habitats, different other habitats other than the boreal as well as the temperate forest, there are tundra, there are wetlands. All these habitats have have no comparison between the carbon capturing with the mangrove ecosystem, seagrass, as well as tidal salt marshes. So they are on the top. They are readily on the top for capturing the carbon. Now, within the coastal belts, as I was talking earlier, within the coastal belts, if you consider any of the one single habitat, say like tropical forest, the upper four components, seagrass, salt marsh, estuarine mangroves, and the oceanic mangroves, and you see at the last one, that is the tropical forest, they have an immense capacity of capturing the carbon in the soil itself. You just imagine in the soil itself. Now you total up, you sum up the different soil as well as living biomass. There is no comparison of tropical forest or for any of the coastal environments or the marine environments, right? In terms of ton of carbon dioxide equivalent to per hectare, right, per hectare. Now, when we are talking about the coastal belts, that is blue carbon habitats, we also need to understand the rate of the sequestration per year of the carbon, right? For example, mangrove, salt marsh, seagrass, estuarine selves, etc. All these can sequester carbon, right? Can capture the carbon, but at what rate? At what rate? So the last column, if you see, that tons of per year global carbon sequestration, that is per year, about 14% is actually being captured by the mangrove itself. 20% is being captured by the salt marshes, 30% by the estuaries, which is considered to be at the top of the different sequesters of the natural habitats. 30%. So 14, 20, 10, 30, 26, all these percentages are creating a very dominant areas where carbon can be captured, where we also have the diversity of that is called as biodiversity, and as well we also have the conservation of those species, and we can also readily capture those carbon which are being emitted, right? Now, one more example, if you see, the coastal blue carbon count to be in different uh, mangroves, salt marshes, as well as on the sea grasses. They are sequestering the carbon in billion tons. 2,813 billion tons of carbon was sequestered in 1990. 4,000 from the salt marshes, 2,000 in sea grasses. So amount of carbon dioxide which can be sequestered by the mangroves, by the salt marshes, as well as by the sea grasses is equivalent to the numbers referred at the below of the slide. Just imagine, that is 1 crore 50 lakh 84,000 equivalent just from the mangroves ecosystem. 2 crore 39 lakh 31,760 of salt marshes itself. So likewise, you just imagine how much amount of carbon we are able to capture through these only coastal belt. At the end of the session, I will just also highlight that the whole coastal areas throughout the world, how much percentage of these habitats are being covered, are being the figures are very interesting. I'll show you at the end. So in term of that particular slide, in consequences of that, mangroves, tidal marsh, seagrasses, every year about almost 2% of mangroves are lost. That means we are losing those important sources or resources of capturing the carbon, about 2 percentages. These 2 percentages are resulting in 240 million tons of carbon dioxide per year. We are losing the value of the mangrove forests. We are losing the value. That is about 2 percentage are being lost, in terms of which 240 million of carbon dioxide is not able to be captured per year. This is just the figure of 1 year. Similarly, about the tidal marsh, about 1.5% of these tidal marshes are also being lost, which is equivalent to 60 million tons of the carbon dioxide, which is not able to be captured due to the loss of those tidal marshes. Similarly, seagrasses are also being lost about 1.5%, and we are not able to capturing the 150 million tons of carbon dioxide per year. Now, if you sum up all these values, 1.9, 1.5, 1.5, so all these values reflect about more than 5 percentages of carbon of the total habitats which are being lost. On the contrary, we are also not able to capture the amount of carbon dioxide in billions and billions of tons every year. So the figure that I shown you of the carbon footprint, that is, we are itself not having the control of conservation of these coastal vegetation. We need to control, we need to have the strategies of conservation of these coastal vegetation just for ourselves. Forget about the other organisms, forget about other living organisms, maybe zooplanktons, plants, animals. But for our survival, we need to control the situation in terms of capturing of the carbon through these blue carbon ecosystems. So eventually, the loss in the blue carbon habitats is shown in this particular slide. Globally, we have lost up to half of the world's mangroves since 1940. Now, I'll just give you some of the examples of these mangroves. That is about Avicennia marina, which is one of the dominant species in the Gujarat. Everyone knows that. Avicennia marina, Rhizophora, all these species were one time dominant, but now we have also majority of the Rhizophora have been lost. Very few patches are being remained for the Rhizophora. There are strategies being built up by the forest department as well as by the national forest agencies, which are conserving as well as which are restoring those Rhizophora species at different areas of the India as well as in the Gujarat. But Avicennia is now considered to be the dominant species, which in found majority in the coastal belts of the Gujarat. We have lost up to half of the total mangrove species since 40s. A quarter of the world's tidal marshes have been lost in 1800s. Right? Tidal marsh, which were considered to be 20% of the consumption of the carbon, 20%, and the world has lost half of its seagrasses in 1990s. You just imagine, we need to culture those seagrasses. Seagrasses are one of the important phases for capturing the carbon. When these systems are damaged, an enormous amount of carbon as carbon dioxide is emitted back into the atmosphere, and where it can contribute towards the climate change, where we started with the topic. So in all, not we are talking not about the different greenhouse gases. I'm just focusing on the carbon dioxide because itself it is the dangerous emission, as it directly reflects towards the living organisms, as we are only the person who are, we are only the population organisms which have generated the problem. So protecting and restoring the coastal blue carbon habitats is a good way to reduce the climate change. It is efficient way as well as it is a safer side to reduce the carbon effect or reduce the carbon damage. The global loss of the coastal and the marine ecosystem is occurring in an alarming rate, currently on an average between 2 to 7 percentage. Right? You just imagine 2 to 7 percentage of this is being lost by the population, because we are not able to now sink those carbons through the blue carbon, the emission which is done. Potential reduced oceanic carbon function and release of the carbon currently stored by the blue carbons sink is not included in the climate projection. Right? We are not including any of the oceanic condition in the climate projections, but then also we are facing these changes. We are facing that blue carbon sinks are being lost annually. The loss of these coastal habitats is often driven by the development, as I told you, economy and ecology. We are on crosses of the ecology as well as economy, but we need to bind hands with the ecology as well as with the economy, because we need to sustain, we need to develop, we need to protect the environment, we need to conserve the environment. Hence the solution is to be found out in terms of sustainable development and sustainable integrity. Now, on summarizing the whole issues, what I came to tell you about in these particular in this session, that is about 151 countries, talking about the blue carbon. 151 countries contain at least one blue carbon ecosystem. As I told you earlier in the couple of slides before, blue carbon has different ecosystems, that is seagrass, maybe mangroves, maybe salt marshes, etc. So about 151 countries contains either of them, that is at least one of the ecosystem. And about 71 country has all these three ecosystems, all these. So just imagine that we have the potential to capture the carbon with the 71 countries which has having all the three habitats: seagrass, sea salt marsh, as well as the mangroves. And 151 countries have the potential to capture the carbon with having only one of the ecosystems. Inclusion of the NDCs, that is nothing but the national determined contribution. 28 countries of NDCs include a reference to the coastal wetlands in terms of mitigation. 59 countries include coastal ecosystem and coastal zone into their adaptation strategies. So now we are also aware about these blue carbon. The agencies have came up with the ideas, with the solutions of developing their ecosystem, especially the coastal ecosystem, to capture the carbon. Overall, the climate mitigation opportunity of blue carbon ecosystem shows that if the half of the annual coastal wetland lose was halted, if the half of the coal was halted, emission would have reduced by 0.23 gigaton carbon dioxide per year, which is also a huge amount, which we were able to capture those carbon if we might have halted that loss of the coastal belt. If the coastal wetlands were restored at the time of about 90s, it would have been potential to increase the annual carbon sequestration about 160 metric tons carbon dioxide per year, which is equivalent to offsetting the burning of 77.4 million tons of coal. So it is a bit contradictory. That is, in 1990s we were not able to restrict the industrial revolution, but we were increasing the carbon emission. Though we at that time we need to decrease the carbon emission, at that time we started to increase. So but wherever we are finding the solution, we need to implement these solutions in terms of blue carbon. So the whole slide is saying that restoration of mangrove forest and the estuaries should be at the top and this circumstances for capturing the carbon. The slide which was I'm talking about, if you see the three values, 83%, 2%, and 50%, they show important figures. 83% of the total carbon cycle is circulated through ocean. that is nothing but ocean, that is nothing but blue carbon zone, blue carbon ecosystem. So 83% of this carbon is being, global carbon is being churning towards the cycle of the whole environment through the ocean, and only 2% is covered with the coastal habitats. Just imagine, 83% of the global carbon through oceans, and only 2% is the resource which we are having. But these 2% has immense accountability for approximately half of the total carbon sequestered in the ocean sediments. So we have 83% which can turn the global carbon cycle through the oceans. We have only 2% which has the coastal habitats throughout the whole countries of about the world, you say, and 50% ability to sequester the total amount of carbon present in the ocean as an ocean sediments. So important thing is that we need to understand the value, the importance, the significance of the blue carbon ecosystem, that is nothing but the coastal vegetation, maybe mangrove, maybe salt marsh, maybe sea grasses. All these habitats are to be regenerated, restored for our development, for the economic development, as well as for the ecological development. Large uncertainties exist in our knowledge of the carbon sequestration in mangroves, and such limitations must be factored into the blueprints of any payment for ecosystem services and blue carbon. So we need to know that these blue carbon has an immense potential of sequestering the carbon in form of carbon dioxide. Nowadays, the trend is of selfies. So as it's an online mode, we need not to have a physical photography or physical things, but we can understand the Earth is being facing this situation in form of climate change, that is global warming. What we can say, this catastrophic climatic environment has been created by the human beings, and the survival ratio is being decreased, and we are just in the selfie mode. We need to notice that if this is continued, then our survival is also in danger. So today what we are doing, just couple of slides just to make you feel free and make you relax. Just we are having a global warming, but this warming is different, and refrigerating ourselves is also different, because we are utilizing refrigerating, which is nothing but emission of one more emission of the greenhouse gases. And we need to warm ourselves, and we need to implement the different strategies, different plannings for sequestering the carbon, and we need to start at this particular moment, or else we will not able to survive for longer duration of time. So thank you very much. We need to protect our world, we need to protect our globe, we need to protect the living resources, because each and every planet, each and every living organism surviving in this planet have the right to live, have the right to feel very much comfortable in their own habitats. The greatest threat to our planet is the belief that someone else will save it. We are the producers, or we are the manufacturers of the problem, and we need to find the solution by ourselves itself. So thank you very much for listening my video, and once again I thank the coordinators, I thank the organizers for organizing the refresher course on the life sciences, and thank you from my side, from Dr. Suhas Vyas from Department of Life Sciences. Thank you all. Thank you very much.